All right, welcome everybody. Hello, my name is Don C. Weber. I guess we're going to let everybody kind of filter out just a minute and everybody filter in. Today I'm going to be talking about architecting safety using cybersecurity requirements and assessments. I do cybersecurity assessments in control environments, meaning that I go, and typically I'm in North America, but in North America I work with a lot of large utilities, some gas and oil, and I go in to do the cybersecurity assessments, meaning that I do go in, I scope an assessment, I work with them to identify what we want to take a look at, and depending on what they're trying to do within that system under consideration, as we call it, I will either do a security assessments, gathering information, identifying what I call implementation issues, vulnerabilities, or I actually do penetration testing, which would be exploiting the surfaces, the attack surface. I look at the protocols that they're exchanging, understand the information that's being exchanged. And as a part of while I'm doing this, I am thinking about the criticality of the systems that are involved. And one of the things that, as I'm going through, I'm working with a lot of different organizations, and I'm a member of the ISA, and I'm also a member of ASTM, which works with the amusement park industry. And I'm noticing that while I was kind of wondering around safety systems, because I do a lot of assessments on regular systems. And actually, I don't know where here we go. This is the clicker. So my concern while we're doing this talk is that I'm concerned about that people are ignoring safety systems, meaning that they're too complex and that it's too dangerous to take a look at them. And that's absolutely wrong. So I started doing some research. So this presentation is about this research. So I want to kind of kick that off. For those of you who don't know or know of me, I've been working in this industry for just over 20 years now. I am a certified SANS instructor, so you can find me. I mean, we're going to go right up to 30 minutes. There is a booth. I conned SANS into having a booth here because I'm really excited about their training, both from a administrative standpoint and a cybersecurity standpoint, but also the SANS industrial control systems group heavily involved with that. And that's just a little bit of my background. I teach the ICS 410 class, and right now we are about to do our second alpha for the new 613 class, which is the penetration testing and security assessments in ICS and OT. Last year, I got my certification in the ISA. I'm now a cybersecurity expert. I've been designated that. I really highly respect the training and the certification process, and I understand the 62443 cybersecurity program and all of the things that are going in it a lot better because I went through that training, so I highly recommend it. As I mentioned, we want to talk about the cybersecurity safety challenge. So I'm going to outline that just a little bit, but then we're going to go into kind of my recommended starting approach to doing a security assessment. Now you can do this, you can use this in a normal environment, but certainly we're going to have my focus here is going to be on some of the safety instruments, the safety systems or safety instrument systems, and then we'll get into a summary, okay? So for those, how many people here actually understand industrial control systems, operational technologies, work in industrial environments? So only a few. All right, so you probably understand this already, but I have to set the stage for everybody else. So when we're talking about our control environments, we're talking about critical infrastructure, whether it's electrical, but more particularly petrochemical, gas and oil. Now, every environment has the risk of damaging the equipment, leading to catastrophic failure. Now, normally, as you can see in this image, what we would expect from a process is that the blue area is like when there's no change in an environment, but there's always change. People moving in and out. I started talking, so the heat started going up in here. All right, so the process control is that green area right there, meaning that we are trying to keep our processes under control. Every once in a while, however, we can't anticipate a condition. Either our equipment didn't anticipate it or react fast enough, or the people, the operators can't react fast enough. And that's the reason why we have people so close to these installations is they have to do certain things. So if they hear an alarm, they'll try to take some action and bring it back under control. Unfortunately, they can't operate fast enough. The condition might not have been predicted within that control loop, as we call it, and then something starts happening. Well, the safety instrumented systems are there to evaluate the conditions and take action as fast as possible. Now, in some cases, if you're not familiar with these types of environments, you would think, okay, it just shuts it down. Well, you can't just shut things down in control environments. You have to take specific action, okay, to prevent some type of catastrophic failure. I mean, one of the best examples that I've been thinking about recently is the liquid natural gas. If you just stop the liquid natural gas process, in other words, if you just turned off all the equipment because you're having a catastrophic failure, all of a sudden things are going to start heating up. That liquid is going to start boiling off more rapidly. In other words, it's changing from a liquid state to a gaseous state because that's where it wants to be. And now you have even more problems. So our safety instrumented systems are in there to prevent the worst case scenario, that catastrophic failure, that explosion. Now, these are the conditions that have been anticipated in these areas, meaning that the reason why the control loop's there, the reason why the safety systems are there, the reason why the people are there is that we know how things fail in the physical world. And so we've tried to plan for that. Okay? Here's an example of some safety instrumented systems. On the left-hand side, you can see what most typical people are considering, meaning the out-of-band management of these systems, meaning that in that center column right there under automation, that would be your controlled process. Okay, we've decided there's a process to decide whether or not we need safety instrumented systems to protect safety, okay, and that is off to the left of that. And you can see that under the safety technologies. All of that is out of band, meaning that it's not on the same network, it's not on the same field bus, information is coming from different sensors, and the action it takes is on different devices. And that is how it's going to protect the process. So most people, when I first introduce them to that, they're like, absolutely, our safety systems need to be air-gapped, they need to be separated. The right-hand side is the integrated, meaning that we're using the same controllers. We're using the same field bus, which is the network that is exchanging information. I have a lot of operators that actually prefer that because it has more direct information from the process. It can take better actions within that process environment. And when you're looking at those devices, even if you can communicate with that controller remotely, the safety module, that little yellow module there, you might not be able to interact with that over the network. In other words, you might have to physically interact with that to configure it. In other words, they've thought of safety, built it into the system, okay? But have they? Okay, so have they ever thought about it from a cybersecurity standpoint? Have they ever considered that you might be able to send a command across the backplane of that device if you can get on that medium and send data to it? And that's where our cybersecurity assessments are going to come in, okay? Now, there is a challenge around this, okay? Because safety is not a cybersecurity consideration, meaning that the programs to identify whether or not we need safety in a system, whether it's a nuclear system or whether it's a petrochemical system, they have some safety groups that actually very specifically do that. They're trained in doing it. An owner and operator, the people that own it, are probably going to have a team that's dedicated to that, and they're bringing in third parties to assist with that from the local government or from some type of standards body, okay? And they ask the questions, is safety required? What level of safety is required? Okay. Now, 62443 does talk about this, and we will get into that in just a minute, meaning that the cybersecurity requirements are that you take a look and understand the digital risks associated with these devices. But right now, the industry, it's a safety system. that is the FA, the HAZOPs, the FEMA, and the LOPA. They're handling that. Well, they need information. They need information about the risk from cybersecurity. There's also this consideration about how a lot of owners and operators outsource the building of these devices, meaning that somebody else builds it and manages and maintains it. In other words, the owners and operators have kind of said, hey, build this for me and I'll make money off of it, okay? So who's responsible if something explodes in that condition? Well, the owner and operator is, because they're responsible for the operations, the risks, the regulatory requirements, and the integrators have just put it in place. But if the integrators never let them look at it, if it's so proprietary that they don't let anybody touch it, investigate it, check the integrity of it, Who's responsible? How do we know that it's actually going to operate if the owner and operators are responsible for it, but the integrators are never telling them how they've secured it? How can they make a decision? So that's one of my concerns as well, is getting the information to the owners and operators so that they can make the decisions and give better requirements to the vendors and integrators, okay? Now, there are international standards associated with cybersecurity for our control environments. Okay, 62443, ISO 27001, they do provide guidance around that. And when you look at these standards, they do, and I know it's kind of an eye chart, okay, but I've kind of listed the things that they actually use to talk about how you have to consider safety systems and cybersecurity associated with that. So we'll talk about those a little bit more. Now, when I was investigating this, and I was challenged because I am the cybersecurity person. I'm not somebody who has implemented these before. I gave this presentation to some of my friends to review, the people from the OT side. And one of the things they pointed out to me is like, hey, Don, why haven't you pointed out this book right here? Okay, and so I went and bought it. This Managing Cybersecurity in the Process Industries. This is written by the Chemical Process Safety Board, or Center for Chemical Process Safety. It's an awesome book. I mean, they're really proud of it. It's about $120 on Amazon, but it's completely worth it. I have a hard copy of it, and I love it. And I've highlighted as soon as I started reading it, I found one of my most favorite quotes of all time. And this helps you understand why we're doing cybersecurity in our industrial control environments and why we also need to take it into consideration when we're talking about our safety instrumented systems. Okay? Now remember, our safety instrumented systems are there to protect the people and the environment. They are there to respond to some common cause failures, the common use cases, and they're supposed to do a specific action when we need them to do it to protect it. And this book, they write about that with this quote: cybersecurity-driven common cause failures have the potential to occur even more frequently because they are a result of intentional action taken by an attacker. What this means is that our safety instrumented systems are in there for just in case. We're going to control it and keep it out of that potential for escalating out of control. However, if somebody gets access to that environment and can send data and signals to our safety instrumented systems, they can make it do something when we didn't expect it, or in the worst case, not do something. And it's more likely that will happen than an actual physical accident. Okay, so I think we need to keep that. This is one of the driving things in my mind when I'm working within these environments. So how are we going to break this down? And so once again, as you notice, we don't have, there's only a few people that are from this industry. So how are we going to talk about and manage the different types of architectures? So let's talk about that real quick. So first of all, this industry, if you're not familiar with it, they don't do anything without referencing an international standard. On one of my first security assessments, I walked in, I was like, hey, here's all the cool cybersecurity things you should be doing. And the process engineer said, hey, yeah, you know what, you're right. Which international standard did you base that decision on? And I had no idea. And so that's how I had to educate myself on 62443 and some of the other international standards. Okay, and if you read through their process in the document 62443-3-2, they have a section that talks about separating safety-related assets. So what they're talking about and they're describing is they're reminding everybody that as you're doing your risk assessments, as you're doing your vulnerability assessments to feed into your risk management process, you need to consider your safety systems. It probably should be a separate consideration, okay? Meaning that you should evaluate your normal process, and then any safety systems related to that, you should evaluate those as a separate system. And I agree with that. Okay, that is, remember back in that one image where I had the two different types of implementations? That's the air gap solution. If it's integrated, how do we separate it out? Well, now we have to, basically what this is saying is that everything within that, if you've integrated every piece of equipment in there, you have to secure it and manage it associated to the critical components, and that's its safety systems, okay? So that is going to help us understand our responsibility around doing security assessments within those environments, okay? There's also this technical report, and this is one of the most valuable, I think, that's out there, Okay, the TR 840009. It's the cybersecurity related to functional safety lifecycle. Basically, this is the ISA telling you this is when you should be doing cybersecurity risk assessments for your safety systems. And they actually had to say you'll do it at the start when you're designing your systems. Then you'll take it into consideration when you're deploying it. And then after it's in place, you'll have to do another security assessment. And so they're talking about the life cycle of your safety systems. You can't ignore them. And actually, because they're associated with safety functionality, you need to pay more attention and be more rigorous. That's me saying it. They're saying it, you should do it on the same schedule and so forth, and that's absolutely right. But I think our driving concerns that we see there on the right, our driving concerns is that we need to do an assessment to understand if somebody gets in, when somebody gets in, and they have access to this environment, can they affect the safety systems? And can they keep them from doing what they need to do at the moment that they need to do it? Okay? All right, we're doing good. So this is actually kind of a diagram of that the 62443 documentation has associated with a good risk assessment program within a control environment. So this would be a risk assessment program that is being managed by that owner and operator that is covering all of their assets. So if they have multiple plants, it's managing all of that. If they have multiple processes in their plants, it's managing all of that. Ultimately, they're going to evaluate every one of their processes separately. They're going to call it a system under consideration. So you identify a small area that is doing the same job, and you evaluate the security implementation within that to ensure that it can do what it's intended to do at the moment it's intended to do it, okay? To include cybersecurity, or excuse me, the safety instrumented systems, all right? So that's how you're going to do that. Now, the high-level risk assessment is the portion of once you've identified that area that you're going to do an assessment on, you do a high-level risk assessment, which is just information gathering. Who's responsible for it? What's the network implementation? Do you have an asset list? Can you make an asset list? You gather all of the, basically you're not touching anything, you're just gathering information. Okay, and then you do a high-level risk assessment. With these technologies, we have these vulnerabilities, these specific vulnerabilities on the known exploited vulnerabilities list. Okay, and here's how we're going to approach our countermeasures initially. Okay, eventually, as a part of that risk assessment process, you have to do a vulnerability assessment. The vulnerability assessment feeds into the detailed risk assessment process. Okay, and that is which feeds the rest of the vulnerability management program. This is where I operate. I operate in the vulnerability assessment field. In other words, I'm going out as a consultant. I'm going to different organizations. I'm assisting their teams in evaluating the system under consideration. Okay, so that can be a penetration test if you need somebody to prove that they can exploit and pivot within an environment, or it can just be a security assessment. How do people get access in? What is our attack surface? Can we fix that? Okay, all of my information feeds back into a risk management program, and they do all of the calculations associated with the security level achieves, and reviewing their security level targets. Okay, the vulnerability management, or the vulnerability assessment. As we're going in, we're trying to identify threats. We're identifying known and unknown vulnerabilities, and then we're looking at and working with the OT team, our liaisons, and talking about the impacts and consequences of some of the conditions within that system under consideration. All right. Ultimately, our output would be going and feeding a detailed risk assessment, detailed risk assessment, which is going back to the risk management team. Okay, and that's all great. And I agree with all of that. We have to have a process. We have to do things to identify systemic issues across our organization. Okay. So that is the first. That's how we're going to approach security assessments within these environments. Normal security assessments, and then also security assessments associated with safety systems as well. So let's talk about the the assessment conversation a little bit. Now, first of all, remember, we're going to gather a bunch of information. If you're doing assessments in this environment, okay, you need to have a lot of information to start. And actually, we have a full process in the ICS 613 class that we're writing and releasing this year. It'll be in the EU, hopefully, I'm hoping March of next year, okay? But if you're going to do an assessment, you need to start by gathering information, understanding, identifying stakeholders, who's responsible for that area, who's the primary OT person that understands that, that process to include the safety systems. Do they understand that? We need to get them involved at the start of the conversation in the initial scoping. Okay, we're going to have them gather as much documentation about the process as possible so that we can use that in our decision making. First of all, we need to outline a test plan, evaluating what we're going to test within that environment, get an agreement from the personnel that operate that environment. Here's our test plan. What are your concerns about that? And then does it meet those assessment goals? Okay. As we're going through, part of the information that we need, we'd like to have as much of the list of technologies and much of know about the data flow within that environment so that we understand that builds into our test plan. What are we concerned about? Okay. And then, of course, if you're evaluating things, you need to think about timeframes, locations, safety training, which goes into some of our testing constraints as well. So this is how you would, this is one of the, or some of the things that you would do as far as scoping a security assessment within a control environment. It's the same thing for if you were scoping it for safety systems. However, you're probably definitely going to want to make sure that some of the OT stakeholders understand the safety equipment as well, because like I said, initially most people are going to say it's safety, don't touch it. However, we have to ensure that it can do the functional safety at the moment it's supposed to do it. So that's why we do need to assess it. Okay. So while 62443 outlines the 7 foundational controls that you would that the risk management team needs to understand about every system under consideration and actually every device that's within that environment. Okay. One of the things that I do is it's a little complicated, and there's a lot to consider in there. And when I start talking to the OT personnel that I need to liaison with to get an assessment of this environment, when I start talking to them, they don't understand that complexity. And so what I found is I was initially breaking this down so it was more palatable for those people that I was going into to do the assessments with. And eventually, this got turned into the SANS ICS 5 critical controls. Tim Conway and Rob M. Lee both came up and published this white paper, and as soon as I saw it, I was like, oh, you guys are already doing what I'm doing. And basically, whenever I'm doing an assessment, I take in consideration these 5 critical controls. In other words, I'm going to assess to these. Now, I don't do all 5 because I'm doing that looking for those implementation issues associated with one system under consideration. So how I usually approach this from a security assessment standpoint is I look at secure remote access first. I check that. How are people getting in and able to get in within that environment? How do they send data to the pieces of equipment we're trying to protect? So I understand that. Then I look at the defensible architecture because we're putting firewalls, we're putting other control countermeasures in place. Okay, but what happens does our own people get access to and through that? Well, you have to use authentication. So I look at defensible architecture next, and then I look at the attack surface, which is basically the risk-based management program, because we're talking about assessments. If I focus on those 3 things, if I start asking questions about those 3 things, then I will get a quick understanding of the environment, the risk that somebody will take advantage of our current implementation and figure out how to address those, give some recommendations around it. Okay? So these are some of the things that I focus on. I start asking questions. So when I do kickoff meetings, this is how I start organizing my test plan. As I mentioned, secure remote access. I'm going to talk about employees. Third parties, there's a lot of vendors and integrators that are allowed access into our environments because we need them. We're never going to get away from that because they are the management experts. Then I get into defensible architecture, start analyzing the network segmentation and isolation, attack surface, and communications. We have to allow communications. Okay, I'm not going to read every single one of those. I think you can kind of get the picture from that. Basically, what I do is I go in and I talk to the OT experts, the people that are familiar with that environment, and I say, here's the things that I'm seeing. Put on your evil bit, or turn on your evil bit, and how would you, with your knowledge, what are you worried about somebody attacking through, right? So that's how I have my discussions within these environments. So just some quick summaries, all right? So first of all, outsourced operations is a huge condition that we need to address within these environments. In other words, we are building these operational environments. They're very complex. They require some talented individuals to make sure that it's doing what it's supposed to be doing in the moment it needs to do that. And that is only associated with the normal part of the process. It's even more complicated when we're talking about the safety part of the process. So owners and operators, you are responsible for the safety of these systems. You're responsible for anything that goes wrong. You're responsible for any type of regulation. You need to be providing requirements to the integrators so that they understand what they're supposed to be providing to you, so that you can give them, so that the integrators, so the owners and operators feel comfortable that it's going to be safe when they need it to be safe. However, owners and operators, you have to tell the vendors and integrators what you expect. Meaning they don't know if your cybersecurity teams are going to do this or if they're responsible for it. If they're responsible for it, you better tell them. If they're responsible for the integrity, you better tell them. You need to tell them when they're responsible to give it to you. Is it once a year? Is it twice a year? Or is it just when the system is decommissioned? Because they don't know those answers, right? It's not typically a part of how we've purchased systems and implemented them. So that needs to be a part of the conversation. Okay, for any large organization, definitely you want to look to the 62443. If you don't have a good risk management program, if you don't have a good cybersecurity program, you should leverage 62443. However, you can't just wait until it's implemented. You do need a quick start. I really like the 5 SANS critical controls because that is how you're going to get protection right now. Get an understanding and improve things right now. And honestly, I think you're going to integrate both of those programs so that you get quick evaluations of all of your different processes, including your safety environments. Okay. So we have to remember. Okay, and I like this quote. Gavin is one of the people that actually, kept me on top of this and made this presentation the way it is. In other words, better. Okay, and he made a quote while we were talking about this. Physical segmentation is ideal as you can air gap and not impede functionality of the safety instrumented systems should a threat warn or response. And what he's saying there is if you have a system that has safety instrumented systems and if you feel like somebody's attacking you, you should island that area. In other words, ensure if you can, depending on the operational requirements, island it so that they can't get in until you understand and have full control of that situation. And that way the safety instrumented systems can operate when they need to. Okay? If you're not doing that, if you're not prepared, you should be asking your team members how you're going to protect those systems when you get ransomware within your control environments. Okay? And then as I always say when I'm teaching, prevention is ideal. We are here to prevent as much as we can, but in a lot of these cases in these environments, we have to operate insecurely. Look, we're always going to operate with vulnerabilities. So detection, if we understand the vulnerabilities, we can detect them, and if you start looking, you'll start finding, so you better be able to respond. All right, so a lot of people that helped me with this, Gavin, Beer Isaac, and so forth. That's my information. We're coming up on it. SANS does have a booth. I think it's F49, but I could be wrong. So what's going to happen is I'm going to leave here, walk out the door, and I'm going to walk over to the booth. So if you have some more questions about this, happy to answer those questions. I actually have the student kit that we're passing out to the students to keep from the new SANS ICS 613 class, ICS OT cyber penetration testing. And if you want to rate this session, go ahead and do that. Thank you very much, everybody.